So, hello everyone to day 2 of GraphQL-Conf. My name is Laurin.
I'm Sahaj, and we both work at the Guild.
So, the Guild, we are basically a group of open source developers, and we maintain a lot of GraphQL-js tooling. So, the most popular ones are probably GraphQL code generator, which helps you like generating TypeScript typings, but also code for other languages. Then we have GraphQL tools, which is kind of a utility belt for building GraphQL servers, and we also have a GraphQL mesh, which is basically a way of converting all kinds of data sources, databases, whatever, into a GraphQL API and merging it together. So we at the Guild, our goal is to build a sustainable open source, and we do so by consulting, educating and bootstrapping companies, and then we look at the things we built there and how we educated them, and then we turn those back into educational content for developers, but also into open source libraries that we share with everyone. Yeah. Our goal is basically to help all kinds of developers, whether beginners or enterprise developers, to build better software. And our goal is to dedicate ourselves to maintaining libraries for the long term. So instead of putting something out and then slowly letting it die, we actually put in the work every day for looking at the issues, looking at the feedback we get from customers, but also from the open source community. And then we iterate on that and try to, step by step, make the thing better. Yeah. And each individual in the Guild actually was doing open source software before we joined the Guild, so the transition was kind of natural. Oh, by the way, this is us in San Francisco. We actually met for the first time after 5 years last week, and we're having a blast there.
So what's our talk today? So we're going to talk about GraphQL-js, or parallel roles GraphQL-js plays as a reference implementation and as one of the biggest used production libraries out there. So brief history about GraphQL-js. So what is GraphQL? We all know it's a query language created by Facebook now it's called the Meta, and when they decided to go public, the creators of GraphQL decided to rewrite everything, and GraphQL-js was born out of as like one of the first public implementations of the GraphQL spec, and one of the first public implementation that you can use out there to begin with. Every year, GraphQL usage is going up. This is the NPM trends. You can see the graph is just taking off every year. GraphQL-js is used by 746K public repos on GitHub. There are more than 10K packages on NPM published that depend on GraphQL-js. And there are a lot of contributors that help sustain GraphQL-js how it is today and help it grow. One of the things when GraphQL-js started, it was written in flow type because Facebook used flow types back in the day. But we all know how the JS ecosystem has evolved, how we all want to add typing to our JavaScript, and TypeScript has won that game for many reasons. And so we took on a project to migrate GraphQL-js code base 2 years ago. We migrated it last year, and it's now completely written in TypeScript. And one of the things we saw migrating to TypeScript was we are able to onboard new contributors, and there are more people who are helping out. And now we have like a full structure on a reviewer team that goes through, reviews the pull request, and merges things. So that's like one thing we have seen migrating our code base to TypeScript. So what is the purpose of GraphQL-js? So what does it mean to be a reference implementation? So how does spec work? So GraphQL has a specification that the technical steering committee and the working group work on, refine it, and that's what get added to a spec. So what it means to add a new feature to a spec is like you go through a RFC process. So the RFC process has 3 stages in it. Stage 0, which is a straw man, where you just identify a problem and you present it to the working group. The stage 1 is like you have a clear problem statement and with some potential solutions to it. Stage 2 is when you actually have most of the solutions laid out, and now you're just getting feedback and like iterating over your solutions with the working group. And at this stage is where you want to have like a working implementation of your feature with GraphQL-js, so we can get feedback from the community and like we can iterate over how we can improve the execution algorithm or like parsing or validation, the different phases we are in. So that's one part of being reference implementation means is like, as the spec gets new things in it, we are also adding new features to GraphQL-js that are spec compliant. So when your proposal goes to stage 3, which means it's accepted, and that's the stage where spec will cut a release and will release all the new features with GraphQL-js. And this is how other implementators of like GraphQL Rust, GraphQL Python, or .NET will go and like take a look and implement the features. They could even do it like stage 2 as the implementer of the RFC decided to like add a new feature. But yeah, so it acts as like a playing field for people to add a new feature and experiment with them. The other role is like adding new features to the spec. So you get to try out all the new feature. Like we have experimental defer and stream support as a RC candidate. And we also have client-side nullability as like a alpha release out there that you can explore. So responsibilities of GraphQL-js. It's very important, like your reference implementation, that it has to be like transparent on how things are being done. So if other maintainers from other implementations come look at the code base and like they can easily follow it and they can just rewrite the code to like their language, because that's how it's used today by many implementators. Like GraphQL Python just looks at GraphQL-js and it takes the pull request and it just creates a Python implementation of them, and that's how they merge it. The other thing is performance. So being a reference implementation is one thing, but the other thing is like it has to be performant, because in the JavaScript, TypeScript ecosystem, this is the only library out there that's every production server using GraphQL is running, or even your client-side code, that's the only thing you get. And this library has to be cross-platform, meaning you can run it on Node.js, you can run it on browser, so GraphiQL runs GraphQL in browser, and you can also run it in Dino or like React Native apps. So it has to cover many aspects of like different JavaScript platform-specific things, so it has to be agnostic in all sense, and it has to be small in size too, which we're trying to improve every release. So problems with GraphQL-js today. So one of the biggest things with GraphQL-js itself is like it requires you to run one version, and it restricts you to only run one version. So within your dependency tree with your node modules, you can only have one version of GraphQL. Otherwise, you're gonna break things. It's gonna be like you're gonna get an error which may be cryptic at times, and it just doesn't work. So this is like one of the bigger problems, because the node ecosystem is moving to ECMAScript modules. So we want to support ESM and CGS at the same time, but now your code could, like one library could be like requiring GraphQL and the other one could be importing, and now you have two instances of it, which makes it a little harder on like how do you actually run it. The other thing is supporting experimental features. So one thing that the spec and the working group needs is like being able to try out these features in production, get some feedback from clients running in production. But the bigger problem is, how do you get all the underlying libraries on the same version as your experimental feature? Or like, let's say if you want to use multiple GraphQL experimental features, like I have defer and stream as experimental, I have client control nullability as experimental. Like the only real solution today is like, you can either fork, you create your own fork, maintain the fork, which is like a lot of overhead. We are asking all the implementators and like all the people who want to give us feedback on how they can just, they have to like cherry pick everything to make it happen, which makes it harder for everyone to give feedback on. And the other thing with GraphQL-js today is like, it's very dependent on how the spec moves forward. So any new feature on spec is how you basically decide what's GraphQL-js is gonna get next. So it's kind of a slow process on how you can try out these new features, and it's a maintenance overhead. So,
yeah, check. Okay, so who actually depends on GraphQL-js? So we have many libraries. We have Apollo, which both has a server and a client that uses GraphQL-js, but we also have Graphical, which is the IDE for doing GraphQL, and everybody uses it. Then we have platforms like Pass, which mobile developers use for building GraphQL APIs that they then can consume from their mobile apps with low code overhead. We have stuff like GraphQL Code Generator, which we are maintaining, which is also heavily using GraphQL-js. Then we have platforms like AWS Amplify, which are also using GraphQL-js. Other clients like Urkel, Yoga, our own server, then GraphQL Helix, which is also some kind of helper for HTTP GraphQL servers. Redwood.js, which is a full stack framework, which basically is built on a lot of tools, and all of those tools depend on GraphQL-js. And also code-first libraries for building your schema, like Potos, or there are many of them. There's GQTX, yeah. And all of those are dependent on GraphQL-js, so GraphQL-js actually has a lot of responsibility for those libraries. So what are actually like concerns when I want to take GraphQL-js and use it for production deployment? Well, there's like two things. First, performance and security. For performance, as Sahaj already said, you want to make sure that the underlying GraphQL algorithm is as fast as it possibly could be, which itself could already be a trade-off, because on the one hand, the GraphQL-js reference implementation should be as readable as possible, but on the other hand, if you want to do really performance stuff, it might get unreadable. So another thing that you want to do is, for stuff that happens frequently or is repeated often, like passing documents or validating documents, you can cache that, because if you get the same query over time, again and again, you don't need to pass and validate that every single time. And then another thing is response caching, which GraphCDN or Stellat is now doing. So you're basically skipping the execution completely, and based on the incoming GraphQL request parameters, you're serving your response directly from the cache. But then, aside from the performance, there's also the security part. GraphQL basically means that you can execute any operation against the GraphQL server if you're exposing it publicly. So what a lot of companies are doing is they're introducing an operation complexity analysis layer, which also limits what operations can be executed. So this layer would go through the selection sets within your incoming GraphQL operation, and then based on the selected fields, calculate the score. And once that goes above a certain threshold, your query would just be rejected. Then what also a lot of companies are doing, but is actually very tricky, is persistent operations. Because first of all, with persistent operation, you in advance during development collect all your operations and then register them on your server. But then in production, you only allow executing those operations. However, if you're doing persistent operations, you now need a management layer for collecting those operations, and then over time, those operations can become a lot, because you have multiple clients, you have mobile clients, and for each of those mobile clients version, with each deployment, new operations come into the store. So you have additional operational complexity and infrastructure problems you need to solve. And then the last and probably most important one is error masking. If there's like a random error within your GraphQL-js resolver, if you're just using the reference implementation, that stack trace is going to leak to the outside world. So what a lot of those servers are doing is they're going through the execution result that results out of the GraphQL execution, and then show if the original error that got thrown is an expected or unexpected error. Otherwise, they will mask it and replace it with a generic error. what are solutions for production servers actually? So as we learned before in the JavaScript ecosystem, all solutions for production servers are actually built around Graphql-js. And if you look in detail into those production servers, or like server libraries, all of them use the parse, validate, execute, and subscribe core functions from GraphqL-js. There's also a GraphQL function within GraphqL-js, but it's not really suited because you can't hook into parsing and validating and then say, I want to cache parse results and validation results. And maybe you don't want to even like cache the parsing results or validating results in memory, maybe in an external store, so it could be shared across multiple servers. So if you look at all those server libraries, you can see very similar patterns. So the question arises, might it be possible that an API or abstraction within GraphqL-js could actually help us solving problems? So we at the Guild actually experimented a lot with this idea. And it started with Envelope, which is basically our GraphQL plugin system. And what it does, it basically takes the parse, validate, execute, and subscribes functions from the GraphQL-js core and provides a simple plugin-based, hook-based API for developers to hook into the before and after phases of each of those stages and then add additional logic. For example, for parse, you could do a parser cache. For validate, you could do a validation cache. And for execute, you could like wrap the original execution algorithm and implement live queries on top, which is something we actually did. And then as we further explored this, we realized that there are some limitations because you can do something before the parsing and after the parsing, but if you want to introduce some new language features and extend how the parser works, that's not really that easy because you have a parser class within GraphqL-js that you can reuse and extend. But then if you have two plugins that want to introduce new experimental features, that will kind of blow up because there's no easy way. And even if you're doing response caching, you could say, okay, I want to introduce that in the execution phase because before execute happens, I have all the relevant parameters, so I can short circuit to the cache. That might work at first, but then as the time passes, you might realize, okay, actually, that's not the best place. Maybe the response caching should happen as early as possible. And that's when we realized, actually, that in order to give the full power of people to like extend GraphqL-js, add all those features, and implement cool stuff, you actually need to own the whole request pipeline from incoming HTTP request to response through GraphQL execution algorithm to HTTP response. And that's why we actually took over Yoga, which some of you might know. It's a very old GraphQL server that got built originally by Prisma, but then got abandoned. And we took it over and tried to implement that vision for ourselves within the server and share it with everyone. And we're still in the stage of experimenting how we can allow developers to build these kinds of plugins and give them the possibility to share those abstractions. Because not every developer that starts using GraphQL is actually in a big corporation or has the resources for solving all those problems over and over again. Even we, with our clients, we saw that within their companies, everyone was trying to solve certain stuff over and over again. So that's our intention why we built this. So I already said a bit, what can't we solve with Envelope and Yoga? So basically, enhancing the GraphQL parser with new features is impossible. As Sahaj already said, for us, we have customers that want to use defer stream. We have customers that want to use one-off. How can we provide them a way of using those experimental features in an easy, convenient way already, although they're not already part of the spec? That's maybe something we can solve with envelope and yoga, because at the moment it requires forking GraphQL-js and then overwriting the resolutions. Then altering the execution algorithm is also something we are not really able to do right now. We might wrap the execution algorithm for implementing stuff like live queries, but that's it. We can't implement defer and stream with envelope and yoga. We need to get into GraphQL-js and fork it. So after some time, we're realizing, okay, what we're actually doing with yoga and envelope, we're just, again, reinventing the wheel. Mercurius has it in some way, Apollo server has it in some way, and maybe in yoga we did it a bit better. I might be biased, but the question for us arises, like, might it be possible that we need better ways of extending GraphQL-js? So it's easier to adopt new features, new language features, and help people to actually test those things before it becomes part of the spec and then is available to GraphQL-js. Because right now, all the libraries in the GraphQL-js, in the JavaScript ecosystem are kind of limited by the evolution of GraphQL-js in terms of innovation, and there is no fork or anything. And I think there shouldn't be a fork. Like, people should be able to rely on GraphQL-js, but I think we all need to think about how we can improve this. So that's actually our talk. I hope you enjoyed it, and if that sparks any conversation, we are happy to talk about stuff. Thank you.